Artificial intelligence systems like ChatGPT have been utilized for scientific research as well as to compose passable essays and perform well on the bar test. But when you ask an AI researcher how it accomplishes all of this, they shrug. Yes, that's the Pandora's box that we're going to discuss. If we open up ChatGPT or a system like it and look inside, you just see millions of numbers flipping around a few hundred times a second, claims AI researcher Sam Bowman, and we simply don't understand what any of it means. He says the ChatGPT utilizes a sort of AI called artificial neural network, which is based on how the human brain functions. Similar to a regular computer program, this type of AI learns over time to recognize and predict patterns rather than having a set of rules explicitly built in. However, Bowman asserts that it's challenging to accurately describe how such systems operate or what they'll accomplish because they effectively train themselves, which, when these programs proliferate, can result in unanticipated and potentially dangerous situations. On Fox's program Unexplainable, which investigates scientific enigmas, unsolved problems, and everything else we discover by delving into the unknowable, Bowman gave a talk. The discussion is part of a new two-part series on AI, The Black Box.
Black box problem. No one, not even the engineers or data scientists who create the algorithm, can understand or explain what exactly is happening inside them or how it arrived at a specific result.
How do programs like ChatGPT function? How exactly do engineers train them? Sam Bowman asserts that the primary method used to train systems like ChatGPT is essentially autocomplete. These computers will be fed a lengthy text from the web. They'll just be required to read a Wikipedia article word for word. After it has seen each word, we'll ask it to predict what word will appear next. It uses probability to accomplish this. It is stating there is a 20% possibility that this is either the or of. Then, since we're aware of the word that follows, we can determine if it is guessed correctly. A genuinely deluxe autocomplete tool is obtained after months and millions of dollars worth of computer time. However, you should improve it so that it behaves more like the thing that you're truly attempting to create. For example, a helpful virtual assistant. Although there are a few distinct approaches, reinforcement learning is the most common one. This works on the fundamental premise that you have to test people's interaction with the system and essentially upvote or downvote comments. When using reinforced learning, you might tell the model something like, alright, make this word more likely because it's the next real word. And alright, make this entire response more likely because the user liked it. And make this entire response less likely because the user didn't like it. So what are the unknowns in systems like ChatGPT? There are therefore two interconnected major unknowns. The first is that we have no actual understanding of what they're doing. We simply have no notion of what any of the millions of numbers spinning around a few hundred times per second inside ChatGPT or a system similar to it mean. We can't look into these things and say, oh, here's what concepts it's using, and here's what kind of rules of reasoning it's using, with a very small number of exceptions. Here's what it does and what it doesn't understand. We simply don't comprehend what is occurring. We constructed it and trained it, but we're unsure of its functioning. What's the other big unknown? We don't know how to reliably steer or control these things, which is another major uncertainty in this context. We can kind of nudge them to do more of what we want, but the only way we know if our nudges were successful is to just deploy these systems and see what happens. We're just sort of guiding these things almost entirely by trial and error. The main difference is that there is a very straightforward description of what it is doing with regular programs, such as Microsoft Word and IBM's chess-playing software Deep Blue. We can state, okay, this portion of the Deep Blue code is computing 7 chess moves out. What do you think the other player would play if we had played this set of moves? We can only describe what each computation is doing in these stories, which are only a few phrases long. So what's the problem here? There is no clear explanation for the AI used by ChatGPT, such as these neural networks. There is no justification for things like checker moves, strategy, or what we anticipate the opposing player would do. All we can truly tell is that there are a lot of small numbers and that they fluctuate between going up and down. Additionally, they all appear to work in tandem to perform a linguistic function. To truly be able to say anything fascinating about how these neurons operate, we lack the concepts that map onto them. Is it possible that we don't know how it works? After all, it is we who built it. The crucial point in this situation is that we didn't truly construct it in the truest sense. We constructed the computers, but after that, we merely provided a rudimentary plan and essentially let the systems evolve on their own. It might be helpful to think of this situation as if we were trying to grow a decorative topiary or a shaped decorative hedge. We plant the seed, and having determined the shape we like, can roughly shape it with clippers. However, that does not imply that we have any knowledge of the biology of that tree. We just started the process, let it run its course, and then attempted to move it a little bit at the conclusion. Does that mean that AI research is investing in mystery boxes? By all means, yes. So if you create a miniature replica of one of these, all it does is learn text statistics. Just discover that a period may come before a capital letter and that the may precede a noun. Then, as they grow older, they begin learning to program, rhyme, or write a respectable high school essay, and none of that was intended. All these varied levels of behavior are obtained by executing the same code. Simply put, you're running it longer and using more data on more computers. A lab doesn't know what a neural network will be capable of when it decides to invest tens or hundreds of millions of dollars in its construction. They can infer that it will have more capabilities than the previous one. However, all they can do is wait and see. As these models grow, we may be able to forecast some facts about them, but not these crucial inquiries about what they're capable of. Additionally, it contributes to some of the worries about these systems.
And we don't have all the answers there yet, and the technology is moving fast. So does that keep me up at night? Absolutely.
One of these models may provide a skill that you don't want. According to the document detailing GPT-4, when it was first trained, it could reasonably guide an amateur person through the process of constructing a biological weapons facility. They also had no desire to use that as a product. They constructed it by mistake. Then, they had to spend countless months working out how to fix it, and how to move the neural network so that when it was deployed in the real world, it would not behave that way. So have you heard of the field of interpretability? Which is the science of figuring out how AI works. The objective of interpretability is to be able to look into our systems and state fairly clearly and with a high degree of certainty what they're doing and why. Simply because of the way they're put up, they can plainly illustrate what is occurring within a system. It's comparable, in my opinion, to biology for living things or neurology for the mind. One of them is the objective of simply trying to determine the proper way to examine what is happening within a system like ChatGPT by learning how to sort of examine all these numbers and discover intriguing ways of outlining what they might mean. Eventually, we'll be able to simply examine a system and make a judgment about it. The alternative study direction is called interpretability by design, attempting to develop systems whereby each component has an understandable meaning via design. However, both of them have proven to be extraordinarily challenging in practice. Unfortunately, I don't believe we're moving very quickly on either of them, and what makes interpretability so hard. For the same reason that cognitive science is challenging, interpretability is challenging. We frequently lack adequate responses to queries about the human brain. We're unable to examine someone's thought processes or deduce their logic from observing how their neurons fire. Because we don't even have the tidbits of intuition that we've learned from humans, it may be even worse for those neural networks. We have no idea what we're looking for. Just the fact that the numbers get so large here is another aspect of this. These neural networks include hundreds of billions of connections, therefore, even if you can figure out a way to gaze at a small portion of the network for a few hours, you still wouldn't be able to finish explaining it all without everyone on Earth doing it. This story is actually about the unknown. We don't know how it's working or when it is working. Neither do we have any idea of how to control it institutionally. Texts like ChatGPT are another example of a mystery box. What's your thought on this mystery of AI? Let us know in the comments. Make sure you like and subscribe.